So here is another question on temperature measurement. So it is given that the pressure of air in the bulb of a constant volume gas thermometer is given by 73 centimeter mercury at 0 degrees Celsius and 100 centimeter mercury at 100 degrees Celsius. So pressure at 0 degrees Celsius and 100 degrees Celsius, that is given. Calculate the pressure at the temperature of 20 degrees Celsius. So again, this is based on constant volume gas thermometer. Okay, so here is an important formula, working formula for these kind of situations, which is based on constant volume gas thermometer. Here the formula is, let's say we have a pressure at any particular temperature which is denoted by T. We know that pressure at any particular temperature T, and we have the pressure at the lower fixed point divided by pressure at the upper fixed point minus the pressure at the lower fixed point. This gives us the particular temperature for that scale. So we have the pressure reading at that particular temperature, we have the pressure at the lower fixed point for that scale, we have the pressure at the upper fixed point for that scale, and again the pressure at the lower fixed point at that scale. That gives us the temperature reading at that particular temperature for that scale. So here we have the Celsius scale. Okay, so it is T degree Celsius. So this is the pressure reading at that particular temperature. This is the lower fixed point is at 0 degrees Celsius, and the upper fixed point it is at 100 degrees Celsius. Again this is 0 degrees Celsius. So here if you see, if you compare this with the data given in the question, for the constant volume gas thermometer, the pressure at the lower fixed point LFP, that is 0 degrees Celsius, it is equal to 73 centimeter of mercury, and the pressure at the upper fixed point, which is P100, let's say, that is equal to 100 centimeter mercury. Okay, and we have to calculate the pressure at T equals to 20 degrees Celsius. Okay, so we can call it P20. So here T is equal to 20 degrees Celsius, which is given. We have to calculate PT, and POFP and PLFP, they are already given. So simply what we have to do is we have to put the values and get the result. So here simply we'll put the values. So that implies PT minus PLFP, which is P0, pressure at 0 degrees Celsius, lower fixed point, that is equal to 73 centimeter mercury, and this is pressure at the upper fixed point 100 centimeter mercury minus 73, and the temperature is 20 degree Celsius. So that implies and this is into 100. Okay, here another thing which I have forgotten is that here we have to multiply. Okay, sorry, by mistake I just forgot. Here you have to multiply the total number of divisions in between the upper and lower fixed point. Okay, you have to multiply that. upper fixed point minus lower fixed point. So for degree Celsius it is 100 minus 0. Okay, this. So here we have to multiply 100 degrees Celsius minus 0. So that implies we have Pt minus 73 by 27 is equal to 20 by 100. That implies Pt minus 73 is equal to 20 by 100, which is equal to 1 by 5. So 1 by 5 into 27. That implies Pt is equal to 73 plus 27 by 5, which is equal to 73 plus 27 by 5. 25 into 5, 25. So it's 5.4. 5.4. So it's 78.4 centimeter mercury. So pressure at 20 degree, that is equal to 78.4 centimeter mercury. So here again I am repeating that this working formula, here I miss this part, to multiply the difference between the upper fixed point temperature and the lower fixed point temperature. Everything else is the same. Pt, which is the pressure at any specific temperature minus the pressure at the lower fixed point, divided by the pressure at the upper fixed point minus the pressure reading at the lower fixed point. Here just you have to multiply the difference between the upper fixed point temperature reading and the lower fixed point temperature reading, which is, in case of Celsius scale, it is 100. So that is equal to that particular temperature. This is used as a temperature measurement relationship for constant volume gas thermometer. So if you remember this formula, it will become very handy to solve these numericals quickly. So this is the working formula. Just add this part which I missed previously. Okay, this part I missed. So just the difference between the upper fixed point temperature and the lower fixed point. Okay, so this is the thing. So here is another question on temperature measurement and temperature scales related to that. So it is given that the resistances of a platinum resistance thermometer at ice point, steam point and boiling point of sulfur are 2.5 ohm, 3.5 ohm and 6.5 ohm respectively. Find the boiling point of sulfur. Note, the ice point and steam point measure 0 degree Celsius and 100 degree Celsius respectively. Okay. So again, the reason why I am including these kind of questions is because it is based on temperature measurement. So far, let me just give you a quick background on this whole thing. So we are discussing temperature measurement. Okay, so far we have discussed questions on constant volume gas thermometer. Okay, so here temperature is measured as a function of pressure, P, pressure, that. Here the question is based on electrical resistance thermometer or platinum resistance thermometer. So we'll just call it resistance thermometer. So this is electrical resistance thermometer or simply resistance thermometer. Okay, this. So here the main parameter which is used to measure temperature is resistance. Here it is pressure, here it is resistance. We also have another temperature measuring device, which is thermocouple or voltage based thermometer. Okay, voltage or EMF based thermometer. So here the main measuring parameter is the electromotive force, EMF or voltage, whatever. This is used to measure temperature. So here the main working formula for measuring the temperature will be here, let's say we have the resistance value at any particular temperature, okay, according to any scale. Then we have the resistance value at the lower fixed point divided by the resistance value at the upper fixed point minus the resistance value at the lower fixed point. This we multiplied with the difference between the temperatures at the upper fixed point and the lower fixed point. This gives us the temperature value. So here temperature is measured with respect to the resistance readings. So if you remember, in constant volume gas thermometer we did the same for pressure, okay, where temperature was measured as Pt minus PLFP by PUFP minus PLFP into TUFP minus TLFP. This. So here same thing is done but with resistance readings. Their pressure reading was used, the pressure values. Here the resistance values are used. Okay, and in thermocouple the EMF values will be used. So in case of R, here we'll be using voltage. You can use voltage readings or EMF, whatever symbol you want to use will be the same. Here the voltage in volts, those readings will be there. So we'll be discussing questions related to that. So for now, focusing on the question, so you got the idea of the main working formula. This is the main working formula for electrical resistance thermometer or platinum resistance thermometer. So here it is given that the resistance values at ice point, that is 0 degree Celsius, which is the lower fixed point, that is equal to, the resistance value is equal to 2.5 ohm. The resistance at steam point, which is the upper fixed point, the boiling point is generally the upper fixed point in degrees Celsius, so that is given as 3.5 ohm. Okay, and the resistance at the boiling point of sulfur, okay, the boiling point of sulfur, that is equal to 6.50 ohm. We want to calculate the temperature of the boiling point of sulfur. So here we'll do that. So the temperature at the boiling point of sulfur is equal to the resistance at the boiling point of sulfur, which is equal to 6.50, minus the resistance at the lower fixed point or the ice point, which is equal to 2.50, by resistance at the upper fixed point, which is the boiling point of water or steam point, okay, boiling point of water or steam point, whatever that. So that reading is equal to 3.5 minus the lower fixed point, which is the ice point, that is equal to 2.5, multiplied with the temperature difference between the upper fixed point and the lower fixed point, that is steam point minus ice point. That is equal to, here it is mentioned specifically in the question that the steam point and ice point, they measure 100 degrees Celsius and 0 degrees Celsius. So it is 100 minus 0. So this is equal to, it is coming 6.5 minus 2.5, that is equal to 4. 3.5 minus 2.5, that is equal to 1. 100 minus 0 equal to 100. So it is equal to 400 degree Celsius. So the temperature of boiling point of sulfur is equal to 400 degree Celsius. This. Okay. So this is the main working formula for electrical resistance based thermometer. Okay, this is this.